Okay, good day. So now we are continuing our discussion on the nature of numbers. And if last meeting we talked about natural numbers, this time we will focus on a new kind of number which is called the integer. So integers, right? So historically, an agricultural type society would need only natural numbers. But what about a subtraction such as 5 minus 5? So if you subtract 5 from 5, you need a new number to represent that answer. And so that number we now know to be 0. And thus it was invented so that 5 equals 5 plus 0, right? So if this new number is annexed to the set of natural numbers, a set called the set of whole numbers is formed. So the symbol for set of whole number is W. uh, Written fancily with two bars, if you can see it here. So whole numbers are natural numbers plus 0. This one annexation to the existing numbers satisfied society's needs for several thousand years. However, as society evolved, the need for bookkeeping advanced, and eventually the need to answer this: can we annex new numbers to the set W so that it is possible to carry out all subtractions? So the numbers that need to be annexed are the opposites of the natural numbers. The opposite of 3, which is denoted by negative 3, is the number that when added to 3 gives 0. If we add these opposites to the set W, we have the following set. Set Z, where Z is the set of integers. So the set of integers is the set of whole numbers plus all the opposites of the positive integers or the natural numbers, which is the negative of those. This set is known as the set of integers. It is customary to refer to certain subsets of Z as follows. So we have the positive integers or the natural numbers or counting numbers, 1, 2, 3, 4, and so on and so forth. Then we have the 0, and then we have negative integers, negative 1, negative 2, negative 3, and so on and so forth. Now, with this new enlarged set of numbers, are we able to carry out all possible additions, subtractions, and multiplications? Well, the answer is not really. But before we answer this question, let's review the process by which we operate within the set of integers. If you have had algebra, then this should be easy for you. You might recall that the process for describing the operations with integers require require the notion of absolute value, which represents the distance of a number from the origin when plotted on a number line. So the absolute value of x denoted by two vertical bars enclosing x is defined as the absolute value of x is equal to x if x is greater than 0 or negative x if x is less than 0. Okay, so let's answer the following. Find the absolute value of each number. For letter A, the answer is 5. For letter B, the answer is still 5. So if you have a negative number inside absolute value brackets, then you have to convert that to positive. And letter C as well. Now, if we evaluate the number negative 3, that's actually equal to positive 3. And then if we absolute value that, that still gives us positive 3. So everything here is just positive. How about adding integers? So if one or both of the integers is 0, then we use the identity property to write x is plus 0 equals 0 plus x equals x for all x. We could introduce the addition of non-zero integers in terms of number lines. And we note that if the numbers we're adding have the same sign, the result is the same as the sum of the absolute values, except for a plus or a minus sign, since their directions on a number line are the same. If we're adding numbers with different signs, their directions are opposite, so the net result is the difference of the absolute values with a sign to indicate final position. So here is a summary of the steps you need to take when you add integers. Step 1, check to see if at least one of the integers is 0. If so, then x plus 0 equals 0 plus x is equal to x. Check to see, step 2, if the signs are the same. If so, then the positive plus positive equals positive, negative plus negative equals negative, and you just add the absolute values of both values. Step 3, check to see if the signs are different, and if so, then positive plus negative is equal to the sign of the larger, and then subtract the smaller absolute value from the larger one. Anyway, this is easier to understand if we have some examples. So for example, letter A, 41 plus 13, this is 54. Since both are positive, then you simply add them and then carry the sign of positive. Here, negative 41 plus negative 13. Well, both are negative, so you just add them and then bring the sign along with them. So 41 plus 13 is 54, and since both are negative, you have to include the negative sign as well. So here's an example of a positive plus a negative. So which number is greater in terms of the absolute value of the numbers? Clearly 41, the positive number is greater. So what we do is we subtract the two, 41 and 13. The difference is 28. And then we carry the sign of the larger number, which is the larger number happens to be positive. So our final answer should also be positive. Okay, so letter D, negative plus positive. Negative 41 plus 13. So it's the same thing, no? We see that both numbers have opposite signs. So we have to subtract them. And the difference of 41 and 13 is 28. And since the larger number is negative, so we have to carry the negative sign into the final answer. How about if we multiply integers? So for whole numbers, multiplication is defined as repeated addition, since we say that 5 times 4 means 4 plus 4 plus 4 plus 4 plus 4, or 5 addends. However, we cannot do this for the integers since negative 5 times 4 does not make sense. So, I mean, negative 5 addends do not make sense. So even though you may remember how to multiply integers, let's consider 4 patterns. First pattern is positive times positive. So we know how to multiply positive numbers since these are just natural numbers. The product of two positive numbers is a positive number. When you multiply a positive number and a negative number, then what you do is just you multiply them and then you carry the negative sign. And for negative times positive numbers, it's the same. You just multiply and then you carry the negative sign. But if both are negative numbers, if you multiply negative numbers, then you have to convert that to positive. You multiply them and you convert that to positive. So, so if both numbers are positive, then their product is positive. If both numbers are negative, then their product is positive as well. And only when their signs are opposite do we have a negative answer. So, like here, for example, 41 times 13. So the answer is 533. And since both numbers are positive, the final answer is positive. Negative 41 times negative 13. Well, both are negative. So the answer has to be positive after multiplying them. So letter C is an example of a positive times negative example. So since the signs are opposite, so after you multiply them, you should carry a negative sign into the final answer. And the same is true for letter D. One of the numbers is negative, the other is positive. So the signs are opposite. So when you multiply them, you should put a negative sign in the final answer. So how about subtraction of integers? So let's see what. To subtract, add the opposite of the number being subtracted. So in symbols, x minus y is equal to x plus negative y, right? So when you're subtracting, you're just it's the same as adding the opposite of the second number or the number of being subtracted. For example, 41 minus 13, right? 41 minus 13 is just equal to 41 plus negative 13. So as you can see, the signs are different. One is positive and the other is negative. So you subtract them and you carry the positive sign into the final answer because the positive number is bigger. So letter B is a sample. It's example of a positive minus a negative. So again, no, what you do here is 41 minus negative 13 is the same as 41 plus the opposite of negative 13, which is positive 13. So it ends up, you're just adding the two. 41 plus 13 equals 54. So negative minus positive, negative 41 minus 13 is the same as negative 41 plus negative 13. And that means that you have to add both of them because both are negative. And so you have to carry the negative sign into the final answer as well. So now if you have negative minus negative, that's the same as negative 41 plus 13. So So this is the same as negative 41 plus 13. And we have to subtract both numbers because they are opposite signs. And 41 minus 13 is 28. And we carry the negative sign because the negative number is greater. So how about division of integers? So division is defined as the opposite operation of multiplication. If a, b, and z are integers where b is not equal to 0, then division A divided by B is written as A over B and is defined in terms of multiplication so that A over B equals Z means A equals B times Z. Since division is defined in terms of multiplication, the rules for dividing integers are identical to those for multiplication. We summarize the procedure for x divided by y, but first, we must make sure y is not equal to 0 because division by 0 is not defined. So if you divide a positive integer with a positive integer, the answer is a positive integer. And the whole number part is a division between the absolute values of the two numbers involved. And the only other time that your answer is positive is when both the dividend and the divisor are negative. So if you divide a negative number with another negative number, the answer is a positive number. And if the signs are opposite, then you should get a negative and final answer. So here, letter A, 12 divided by 6 is 2. And since both dividend and divisor, the number above and below the numerator and the denominator, are both positive, so the final answer should be positive as well. Here in this case, the numerator is negative and the denominator is positive, so the signs are opposite. So your final answer after dividing should have a negative sign. And the same is true for letter C. The dividend and the divisor have opposite signs, so your final answer should be negative as well. And finally, for letter D, both are negative, so the final answer should be positive. Notice that for A divided by B, we require B divided by 0. So why do we not allow division by 0? We consider two possibilities. What does this mean for A divided by 0 to be equal to X? Is there such a number X so that this makes sense? We see that any number X would have to be such that A equals 0 times X. But 0 times X equals 0 for all X. And since A is not equal to 0, we see that such a situation is impossible. That is, A divided by 0 does not exist. Okay, so this doesn't make sense because A should be non-zero, and yet X times 0 requires it for A to be 0. So A cannot be 0 and not 0 at the same time. That just doesn't make sense. How about 0 divided by 0? Is there such a number? We see that any X makes this true since 0 times X equals 0. So this looks promising. You can multiply X by 0 and you get 0. So 0 divided by 0 is X. So this should make sense. However, this leads to certain absurdities. So this means that 0 divided by 0 can take on any value. It can be equal to 2, it can be equal to 5, and this checks out. And that just doesn't make sense for one fraction to have multiple values. Mathematics, it makes the language imprecise. So therefore, this one, we actually say that 0 divided by 0 is indeterminate. The term is indeterminate. And so this is not allowed as well. Okay, thank you for listening. I think that was the last slide. And so how do I stop recording? Goodbye.